So last week we were working on syllogistic logic with like the weird symbols and trying to form an argument. And this week we're gonna learn a little more in depth on that. So today's goals are to learn how to derive a conclusion that follows validly from a set of premises, learn how to use a Venn diagram to determine the validity of a conclusion, learn how to dissect convoluted wording or extraneous material, and compare the views of Aristotelian and modern logicians. And the quote of the day is, "At each increase of knowledge, as well as on the contrivance of every new tool, human labor becomes abridged." And that's from Charles Babbage. He was a logician and a mathematician. So today's topics are deriving conclusions, Venn diagrams, idiomatic arguments, and the Aristotelian view. Deriving conclusions. This exercise gives you premises and has you derive a conclusion that follows validly. Do the problems in a dual manner. First try intuition, then use rules. Using intuition, read the premises slowly, say therefore to yourself, hold your breath, and hope that conclusion comes. If you get a conclusion, write it down. Then symbolize the argument and test for validity using the STAR test. The rule approach uses 4 steps based on the STAR test. So first, you translate the premises, STAR according to the STAR test rules, and see if any rules are broken. Next, you figure out the conclusion letters. Then you figure out the conclusion form. And lastly, add the conclusion and do the STAR test. This seems really confusing, but we're gonna go over it more in the next few slides. So step 1, translate the premises into logic, start the distributed letters, and see if rules are broken. If you have 2 right-hand stars or a capital letter that occurs twice without being starred exactly once, then no conclusion validly follows. So you can write no conclusion and stop. Step 2. The conclusion letters are the 2 letters that occur just once in the premises. So if your premises are little x is big A and little x is big B, then big A and big B will occur in the conclusion. Step 3. Figure out the form of the conclusion. If both conclusion letters are capitals, use all or no conclusion if every premise starts with all or no. Otherwise, use a sum conclusion. If at least one conclusion letter is small, the conclusion will have a small letter, is or is not, and then the other letter. Always derive a negative conclusion if any premise has no or not. Here are some examples using all and no. From premises all and all, derive an all conclusion. From all and no, derive no. The order of the premises doesn't matter, so from no and all, derive no. Any sum premise gives you a sum conclusion. From all and some positive, derive sum. From all and some is not, derive some is not. From no and some positive, derive some is not. If the premises have a small letter, but the conclusion has to have 2 capitals, derive sum. From little x is big A and little x is big B, derive sum big A is big B. From little x is big A and little x is not big B, derive sum big A is not big B. And if at least one conclusion letter has to be small, then the conclusion will have a small letter, is or is not, and then the other letter. So from little a is little b, and little b is big C, derive little a is big C. From little a is big C and little b is not big C, derive little a is not little b. From little a is little b and little b is little c, derive little a is little c. Always derive a negative conclusion if any premise has no or not. Step 4. Add the conclusion and do the star test. If it's invalid, see if you can make it valid by reversing the letters in the conclusion, such as changing all big A is big B to all big B is big A, or some big A is not big B to some big B is not big A. The order matters with these two forms. Finally, put the conclusion back into English. So here are some examples. Suppose we want to derive a valid conclusion using all the English premises below on the left. We first translate the premises into logic and star. So we have some cave dwellers use fire, that's some big C is big F, and all who use fire have intelligence. All big F starred is big I. No rules are broken. C and I will occur in the conclusion. The conclusion form will be sum is. We find that sum C is I follows validly, and so we can conclude some cave dwellers have intelligence. Equivalently, we could conclude some who have intelligence are cave dwellers. Or suppose we want to derive a valid conclusion using all of these next premises. Again, we first translate the premises into logic and star. No one held for murder is given bail, so we make that no big M starred is big B starred. Smith isn't held for murder. Little s is not big M starred. Here, M is starred twice, and there are two right-hand stars, and so the rules are broken. So no conclusion follows. Do you intuitively want to conclude Smith is given bail? Maybe Smith is held for kidnapping and so is denied bail. Let's take yet another example. Gensler is a logician. Little g is big L. Gensler is mean. Little g is big M. No rules are broken. L and M will occur in the conclusion. The conclusion form will be sum is. Since sum L is M follows validly, and we can conclude some logicians are mean. Equivalently, we could conclude some who are mean are logicians. So now we're going to be moving on to Venn diagrams. Don't worry if you were confused on the last topic. I'll post a worksheet later with some sample problems and you guys can refer back to these slides for additional support. So how are Venn diagrams used in logic? Having learned the STAR test, we'll now learn a second test that's more difficult, but also more intuitive. Venn diagrams have you diagram the premises using 3 overlapping circles. We'll apply Venn diagrams only to traditional syllogisms, meaning 2 premise syllogisms with no small letters. Here's how to do the Venn diagram test. First, draw 3 overlapping circles, labeling each one with one of the syllogism's letters. Then draw the premises as directed in the next few slides. The syllogism is valid if and only if drawing the premises necessitates drawing the conclusion. So first, draw the 3 overlapping circles. So circle A contains all A things, circle B contains all B things, and circle C contains all C things. The central area where all three circles overlap contains whatever has all three features, meaning A, B, and C. Three middle areas contain whatever has only two features, for example, A and B but not C. Three outer areas contain whatever has only one feature, for example, A and B but not C. A, for example, just having one letter like just A, not B and C. Three outer areas contain whatever has only one feature, so for example, A but not B or C. Each of the 7 areas can be empty or non-empty. We shade areas known to be empty. We put an X in areas known to contain at least one entity. An area without either shading or an X is unspecified. It could be either empty or non-empty. So draw the premises as followed. Whenever you have no A is B, shade wherever A and B overlap. This means, for example, no animals are beautiful means nothing in the animal circle is in the beautiful circle. So you shade it in. The next example, whenever you have some A is B, put an X on an unshaded area where A and B overlap. This means some animals are beautiful means something in the animal circle is in the beautiful circle. Whenever you have something like all A is B, shade areas of A that aren't B. This means all animals are beautiful means everything in the animal circle is in the beautiful circle. And final example, whenever you have some A is not B, put an X in an unshaded area in A that isn't in B. So that means some animals are not beautiful also means something in the animal circle is outside the beautiful circle. So shading means the area is empty while, So shading means the area is empty while X means it contains something. Follow these 4 steps. For now, you can ignore the italicized complication. Draw 3 overlapping circles, each labeled by one of the letters. First, draw all and no premises by shading. Then draw some premises by putting an X in some unshaded area. When X could go in either of 2 unshaded areas, the argument is invalid. To show this, put X in an area that doesn't draw the conclusion. I suggest you first put X in both areas and then erase the X that draws the conclusion. If you must draw the conclusion, the argument is valid. Otherwise, it's invalid. Here are valid and invalid examples. So here we have all H is D, no F is D, therefore no H is F, and that's valid. So we draw all H is D by shading areas of H that aren't in D. And we draw no F is D by shading where F and D overlap. Here we've automatically drawn the conclusion no H is F because we've shaded where H and F overlap. So the argument is valid. Here's another example. No H is D, no F is D, therefore no H is F. This one is invalid. We draw no H is D by shading where H and D overlap. We draw no F is D by shading where F and D overlap. Here we haven't automatically drawn the conclusion no H is F, meaning we haven't shaded all the areas where H and F overlap. So the argument is invalid. Here is an example with a premise and a conclusion using the word sum. So we have no D is F, sum H is F, therefore sum H is not D. This one is valid. So first we draw no D is F by shading where D and F overlap. We draw sum H is F by putting an X in some unshaded area where H and F overlap. But then we've automatically drawn the conclusion sum H is not D, since we've put an X in some area of H that's outside D. So the argument is valid. Recall that we draw all and no first, and then sum. I earlier warned about a complication that sometimes occurs. When X could go in either of two unshaded areas, the argument is invalid. To show this, put X in an area that doesn't draw the conclusion. I suggest you put X in both areas and then erase the X that draws the conclusion. Here's an example. So we have no D is F, sum H is not D, therefore sum H is F. So this one is invalid. So first we draw no D is F by shading where D and F overlap. Then we draw sum H is not D by putting X in both unshaded areas in H that are outside D, since either X would draw the premise. So we see that in the Venn diagram on the top. We then erase the X that draws the conclusion, sum H is F. So then we've drawn the premises without drawing the conclusion. So it's invalid. Since it's impossible to draw the premises without drawing the conclusion, the argument is invalid. Since this case is tricky, you might reread the explanation a couple times until it's clear in your mind. So the third part we're doing today is idiomatic arguments. We'll learn how to dissect convoluted wording or extraneous material. Our arguments so far have been phrased in a clear premise-conclusion format. Real-life arguments are seldom so neat and clean. Instead, we might find convoluted wording or extraneous material. Key premises may be omitted or only hinted at, and it may be hard to pick out the premises and conclusion. It often takes hard work to reconstruct a clearly stated argument from a passage. Logicians like to put the conclusion, here italicized, last. So we have Socrates is human, all humans are mortal, so Socrates is mortal. That's little s is big H, all big H is big M, therefore little s is big M. But people sometimes put the conclusion first or in the middle. So for our first example, we have Socrates must be mortal. After all, he's human and all humans are mortal. And in our second example, we have Socrates is human, so he must be mortal, since all humans are mortal. Here, must and so indicate the conclusion, which goes last when we translate into logic. Here are some words that help us pick out premises and conclusion. So phrases that often indicate premises include because, for, since, after all. I assume that, as we know, and for these reasons. And these words often indicate conclusions. Hence, thus, so, therefore, it must be, it can't be. This proves or shows that. When you don't have this help, ask yourself what is argued from. These are the premises. And what is argued to. This is the conclusion. In reconstructing an argument, first pick out the conclusion, then symbolize the premises and conclusion. This may involve untangling idioms like only A's may have to add unstated but implicit premises, using the principle of charity, which is interpreting a speaker's statements in the most rational way possible, and in the case of any argument, considering its best, strongest possible interpretation. Interpret unclear reasoning to give the best argument, then test for validity. Here's a twisted argument and how it goes into premises and a conclusion. So, for example, someone says, "You aren't allowed in here. After all, only members are allowed." So we can take that into a premise conclusion format by stating, "Only members are allowed in here. Therefore, only I think I might have made a mistake here, but when we symbolize it, it's all A is M, therefore U is not A. Since M and U occur only once, we need to add an implicit premise linking these to produce a syllogism. We add a plausible premise and test for validity. So we add the premise, "You aren't a member," which is implicit. Only members are allowed in here, therefore you aren't allowed in here. So we now have U is not M, all A is M, therefore U is not A. So now we're moving on to the Aristotelian view. Historically, Aristotelian and modern logicians disagree about the validity of some syllogism forms. They disagree because of differing policies about allowing empty terms, which are general terms that don't refer to any existing beings. Compare these two arguments. And note that unicorns don't really exist, even though some myths speak of such one-horned horse-like animals. So we have first, all cats are animals. Therefore, some animals are cats. And on the right, we have all unicorns are animals. Therefore, some animals are unicorns. The first seems valid, while the second seems invalid. Yet both have the same form, one that tests out as invalid using our star test. So when we do all big C starred is big A, therefore some big A starred is big C starred, that's invalid. When we read the first argument, we tend to presuppose that there's at least one cat. Given this as an assumed additional premise, it follows validly that some animals are cats. When we read the second argument, we don't assume that there's at least one unicorn. Without this additional assumption, it doesn't follow that some animals are unicorns. So all C is A, therefore some A is C, is valid if we assume as a further premise that there are C's. It's invalid if we don't assume this. The Aristotelian view, which assumes that each general term in a syllogism refers to at least one existing being, calls the argument valid. The modern view, which allows empty terms like unicorn that don't refer to existing beings, calls the argument invalid. I prefer the modern view since we often don't presuppose that our general terms refer to existing entities. If your essay argues that angels don't exist, your use of angel doesn't presuppose that there are angels. If you tell your class all with straight 100s may skip the final exam, you don't assume that anyone will get straight 100s. On the other hand, we sometimes can presuppose that our general terms all refer. Then the Aristotelian test makes sense. Suppose we have an argument with true premises that's valid on the Aristotelian view, but invalid on the modern view. We should draw the conclusion if we know that each general term in the premises refers to at least one existing being. Otherwise, we shouldn't. Consider this pair of arguments with the same form, a form that's valid on the Aristotelian view, but invalid on the modern view. All cats are mammals. All cats are furry. Therefore, some mammals are furry. And the second one says, all square circles are squares. All square circles are circles. Therefore, some squares are circles. The first inference is sensible because there are cats. The second inference isn't sensible because there are no square circles. Some logic books use the Aristotelian view, but most use the modern view. It makes a difference to very few cases. All the syllogisms we have gone over so far out the same on either view. To adapt the star tests to the Aristotelian view, word it so that each capital letter must be starred at least once, instead of exactly once. To adapt Venn diagrams to the Aristotelian view, add this rule. If you have a circle with only one unsheeted area, put an X in this area. This assumes that the circle isn't empty. So for homework, I will be posting 15 questions and a quiz on the last 3 lessons that we've done. And those will be on Google Classroom. So please try to hand those in before next week's class. And if you haven't already handed in last week's homework, please do that one too. Thank you for coming. If you have any questions, please let me know.
Are you gonna grade it?